Hey, we're going to be going over STAAR Review Day 5, System of Inequalities. So this is a green foldable that you should have. Starting with problem number 1, it says, which region represents the solution to the system of linear inequalities? So we're first going to start with this first system, which says y's greater than or equal to, which means above negative x. So here we have to determine what is the y-intercept and the slope. So the y-intercept, since it's not adding anything, is 0, and the slope is -1. So looking at these two lines that are graphed, the one that has a y-intercept of 0 and a slope of -1 is this line right here. So what I need to do next is I need to graph everything greater than that line. Remember that greater than or equal to means everything above the line. So everything above the line would be this side of the line, above it. If you're not sure which side is above or below, draw an arrow above and draw an arrow pointing down, an arrow up and an arrow down. Above is everything above the line, so everything upward for the line. The next one we're looking at is the second line, which is y is less than or equal to x minus 2. It has a y-intercept at -2 and a slope of 1. So that symbol right here means less than or equal to, which means below the line. So if I draw an arrow going up, above the -2 and then below the -2, you want to shade below. So everything below the line would be this side of this line. So knowing that we have these two sides that are shaded, we want to find what's called the overlapping region. So your solution is whatever overlaps. So looking at my graph, which region, A, B, C, or D, had a double shaded region? That would be this one, which is region A. So our solution would be A. Problem number 2, which region represents the solution to the system of linear inequalities? So again, we'll start with this first line. Y is greater than or equal to 4 minus 2x. So the y-intercept is +4, which means it's this line right here. So what I need to shade is everything greater than or equal to. That symbol means above the line. Again, if I'm not sure, I'm going to draw an arrow going up and an arrow going down from the y-intercept. Above the line would be everything on this side of the line. Next, we look at the second line, which says all y's less than or equal to -2 minus 2x. So here is the -2, and it's this line right here. Next, we look at this inequality, which means everything below the line. So below the line would be this side of the line. So I shade everything below. The question is, which is our solution? The solution is your overlapping section. You'll notice that one had this side of the line and one had this side of the line. There is no overlapping region. So this is actually, there is no solution to this system. Problem number 3, Mr. Heisman would like surprise birthday cupcakes delivered to his wife's office. Muffin Top, I'll use MT, charges $1.50 per cupcake and an $8 charge for delivery. So that's $150x plus $8 for a delivery. Next, we have Sweet Treats that charges $2.05 per cupcake and a $4 delivery fee. So this one, we're going to use ST for Sweet Treats, and we're going to represent it as 205x for a cupcake plus the $4 delivery. The problem says, what is the minimum number of cupcakes he needs to purchase in order for Muffin Tops to have a lower price than Sweet Treats? So here we want Muffin Tops to be lower than Sweet Treats. So we're going to go ahead and set up our inequality with putting the Muffin Top, which is $1.50x plus 8. When is that going to be less than Sweet Treats, which is 205x plus 4? So here I just set up my two inequalities. When is this going to be less than this amount? Muffin Top less than Sweet Treats. So we just have to solve our system of inequalities. We have two inequalities and we just have to solve them. So here we're going to go ahead and subtract the 4 from both sides. When I subtract 4, I end up with 150x plus 4 is less than 2.05x. Subtract $1.50x from both sides, and we end up with 4 is less than 55 cents x. Then we divide by 0.55. So in my calculator, we're going to put 55 cents. We need to divide it by 4. and we end up with 0.13. I apologize. I did that incorrectly. It should have been 4 divided by 55 cents. We're dividing both sides by 0.55. So by doing that, we end up with 727. So 727 is less than x, or x is greater than 727. So any value above 7.27. So here, if you look at your answer choices, we have 6, 7, 8, or 12. So our solution is any x value greater than 7.27. What is the first whole number that is greater than 7.27? That would be 8. So 8 is the number of cupcakes, the minimum number of cupcakes that you would have to order in order for muffin tops to be less than sweet treats. Problem number 4. A home improvement store took inventory of its 10-pound and 12-pound hammers in stock and counted a total of 23 hammers. The total weight of these hammers is less than 245 pounds. What is the maximum number of 12-pound hammers that meets these conditions? So here we need to write our problem. We know that x plus y, which means all of the hammers together. The 12-pound, I'll use X for the 12-pound, or sorry, 10-pound, since they go over 10-pound first, and Y stands for the 12-pound hammers. So determining which one is which, knowing that together we have sold a total of 23. So I'm going to put here X plus Y equals 23. The next thing we know is the weight. So it says it's 10 pounds for the X's plus 12 pounds for the Y's. And it says that we have a total weight that is less than 245 pounds. So this is what I wrote my inequality. Next, it wants us to figure out what is the maximum number, so the most number of 12-pound hammers that meets this condition. So since we're looking for 12-pound hammers, we're solving for y. So if we're looking to find the y value, that means that I want to have a y value in this inequality. I want to get rid of the x. So we need to figure out, using the first inequality, what is the x equal to? Well, if I move the y over, x is equal to 23 minus y in the first inequality. This is the same thing. These two things mean the same thing. So now we're going to use substitution by plugging this in for x. So 10 right here, here's my 10. Instead of the x, we're plugging in 23 minus y. Plus 12y is less than 245. This will tell me the maximum number of 12-pound hammers. So now we're going to work it out algebraically. So 10 times 23, that's 230. 10 times negative y, negative 10y, plus 12y is less than 245. So that is 230. Together, the negative 10y and positive 12y make 2y less than 245. Now we subtract 230 from both sides, 230. So that's 2y is less than 15. And lastly, we divide by 2. So y is less than 7.5. So the maximum number, which means the most that you could buy, is 7.5. Now, you can't buy 7.5 hammers. So what is the closest whole number value, whole number, less than 7.5? The first whole number less than 7.5 is 7. So our answer is D.